The only difference is what it's representing. So, you got angular position. What is this one? It goes like this. And then you've got angular velocity. So what would your angular velocity be here?
Be negative
And it would just be constant until here.
0.
So what this is saying, if this were like a x versus time graph, then we would be saying that this is our x-axis. So this is positive x. We would be saying that it started somewhere clear out here, then it went backwards for a while, and then it stopped. Right? But in this case, since it's circular motion, you just travel around in a circle. It's like you took that number line and just kind of wrapped it up into a circle. So maybe what happens is you start clear over here at some positive angle, and then you travel backwards, which is counterclockwise. So clockwise is negative. Oh, counterclockwise is positive, sorry. So you travel clockwise around it until you reach some point, and then you just stop. That's the only difference. So the graphs are the same, they work the same way.
Like, I kind of know. Could you explain to me, like, why this is either both positive and stuff?
Yeah.
Because I know, like, when you go counterclockwise, it's positive. Just how it is, like the inner circle and stuff. I'm just confused on
So
how they both work. You know what I mean? How the,
So you remember how we'd have like this? So this is our velocity vector, and we were slowing down. Well, which direction would your position vector be pointing? I mean, not your position vector, but your acceleration vector.
the other way.
Yeah. So this would be positive velocity slowing down. So your velocity is positive, but your acceleration is negative.
Oh, okay.
But what if you're speeding up?
They're both positive.
Right. And then the same thing happens even if you're going this direction. If you're speeding up this way, what are your signs? Velocity is negative, acceleration
Negative.
is also negative. So then you just take that and you kind of wrap it around a circle. So it's saying you're moving this way, so counterclockwise, so that's a positive velocity. And you're speeding up this way, so your angular acceleration also points this way. So that's also positive.
Okay.
So then the next one, what does it say?
It's pointing the other way, so clockwise and it's slowing down.
This time it's this way, so what's that, positive or negative velocity?
Negative.
And then it's slowing down, so which direction is your acceleration point?
The other way.
Yeah, you just
So
point.
that's positive.
Right. It's kind of weird. We don't usually think of like something slowing down as having a positive acceleration. But that's,
Huh. So it's saying like, taking like car perspective, I guess, you're like backing up. Would that be the case? Well, I guess if you still have velocity though.
yeah, so if you put it back into like the straight line idea, and say you're going this way, but you're slowing down as you go that way. So yeah, that could be like your car backing up. But what's happening as you back up?
You're accelerating. Well, velocity is.
Yeah, you are accelerating positively. which seems weird just because you're slowing down. So you're actually, your velocity is changing, tending towards that direction. So you're backing up, and what's gonna happen is you're gonna slow down, stop, and then pull forward, right? So like maybe you backed out of a parking spot, you stop, and you pull forward.
Right.
Because what this acceleration is gonna do, eventually, you'll hit a stop, and then you'll start going forward again, and accelerating in that direction. But the whole time, your acceleration has been the same. So, speeding up or slowing down, the only things that determines if you're speeding up, the signs on your velocity and acceleration will be the same. If you're slowing down, the signs will be different. Other than that, the directions don't matter. They just tell you whether it's positive or negative. So like speeding up and slowing down don't tell you whether or not acceleration is positive or negative. They just tell you whether it has the same sign as velocity, yeah.
So always speeding up, it has the same sign.
Yep.
Okay. Slowing down is different.
Yep. So yeah. So then same thing happens here, you said it's going this way, but it's slowing down. So your acceleration would be pointing this way. The reason, because like just in the normal world, whatever direction, we don't care what direction we're going. If we're speeding up, we call that accelerating. If we're slowing down, we call that decelerating. But in physics, if you were to always say positive everything, and you tried to map out the position of something, say you're like, well, the car starts here, he drives at 20 miles an hour for an hour. You're like, okay, well, maybe he goes this way. And then he stops, and he drives 30 miles an hour for another hour. And you're like, well, does he just keep going this way? And then maybe it says, and then he accelerates at 2 meters per second, or like, 2 miles per hour, whatever. And you're like, what does that mean? Is he speeding up? Is he slowing down? So that's why signs have to be in there, so you can actually tell just from numbers written on a page without like a description of what's going on. You can be able to tell what actually happened. Because otherwise, for example, if you like launched a rocket, you could say, well, we launched it, it was going 500 meters per second, and then it slowed down until it stopped, and then it started speeding up again, and you're like, oh, okay, well, it kept going like this then, because you didn't change the sign of your velocity. But since we can change the sign of velocity, we realize it stopped, and then it turned around, started going the opposite direction. So it's just the only way that scientifically you can actually start to examine things is if you throw signs in there. But yeah, that's how it works. So the signs are the same, speeding up, the signs are different, slowing down.
Okay, cool. So we kind of went over this a little bit last time. Circular motion.
Mm-hmm.
But I guess. Yeah, 25 says the figure below shows the radial acceleration vector AR and 4 successive points on the trajectory of a particle moving in counterclockwise circle.
Okay. 1, 2. All right, so do you remember what the equation for radial acceleration is?
I don't remember.
So A sub R or A sub C. I don't know which one they're using. Yeah, A sub R. So that's radial acceleration or centripetal acceleration. It equals V squared over R.
Oh, yeah.
So we talked about how this one doesn't have to do with whether or not you're speeding up or slowing down. It has to do with how quickly you change direction. So that was like, I think we talked about how as you're going around a corner,